In this video, we're going to look at two force diagram questions. So the first question states that the following force diagram represents a particle that is moving with constant velocity. What are the values of s and t? And the second question states that a train is travelling along a straight horizontal track. A constant driving force is provided by the train's diesel engine, and a constant resistance force opposes the train's motion. Part A asks us to draw a force diagram to illustrate all the forces acting on the train, assuming the train is modelled as a particle. And Part B states that the train has a total resultant force of 5,300 newtons acting in the direction of motion, and the magnitude of the resistance force is a sixth the magnitude of the driving force. Work out the magnitude of the resistance force. Okay, so let's answer the first question. We're told that a particle is moving with constant velocity, and we need to find the values of s and t. So let's take the diagram out and then think about what it means if something is moving with constant velocity. Well, if the particle is moving with constant velocity, then this means the particle has zero acceleration. And if there's no acceleration, then all the forces in the horizontal direction must add up to zero, and all the forces in the vertical direction must also add up to zero. This is because if there's zero acceleration, then according to Newton's second law, F equals ma, the right-hand side would be equal to zero, and so the resultant force on the left-hand side would also have to be equal to zero. So there must be no resultant force either horizontally or vertically. And this means that in the vertical direction, 2s plus 3t is equal to 24. And in the horizontal direction, 3s minus t is equal to 14. And so we now have two equations with two unknowns, which we can solve by either elimination or by substitution. Let's use elimination by eliminating the t's. So we can multiply the whole of the second equation by 3. And so the second equation becomes 9s minus 3t is equal to 42. And in order to eliminate the t's, we have to add both of the equations together. And so we now get 11s plus 0 is equal to 66. And so s is equal to 66 divided by 11, which is equal to 6. And now that we know the value of s, we can substitute it back into one of the equations in order to find t. Let's use the second equation. So we have 9 multiplied by 6 minus 3t is equal to 42, which gives 54 minus 3t is equal to 42. And so 3t is equal to 12, and therefore t is equal to 4. So the final answer is s is equal to 6 newtons and t is equal to 4 newtons. And so that answers question 1. For question 2, part A, we're asked to draw a force diagram to illustrate the forces acting on the train. So let's represent the train as a circle and then draw a horizontal arrow pointing to the right to illustrate the driving force acting on the train due to the train's engine. We can label this force as P. Now draw another horizontal arrow, but this time in the opposite direction to the driving force to represent the resistance force to the motion of the train. And we can label this combined force as F. Next, draw a vertical arrow acting downwards to represent the force of gravity acting on the train, or in other words, the train's weight, and we can label this force as W. And finally, draw a vertical arrow acting upwards to represent the normal reaction force acting on the train by the ground, and we can label this force as R. Okay, so we've now completed the force diagram because it shows all of the forces acting on the train, and so that answers part A. For part B, we need to work out the magnitude of the resistance force given that the train has a total resultant force of 5,300 newtons acting in the direction of motion and a resistance force which is a sixth the magnitude of the driving force. Okay, so as the resistance force is a sixth the magnitude of the driving force, we can represent this as an equation. So we have F is equal to a sixth P, where F is the resistance force and P is the driving force. And if we rearrange for P, we get P is equal to 6F. Now the resultant force is equal to the driving force moving the train forwards minus the resistance force opposing the train's motion in the opposite direction. And so we can write P minus F is equal to 5,300. And then substituting the value of P above gives 6F minus F is equal to 5,300, which gives 5F is equal to 5,300. And so F is equal to 5,300 divided by 5, which is equal to 1,060. So the magnitude of the resistance force is 1,060 newtons. And so that answers part B. Okay, so that's how you answer a couple of force diagram questions. If you found this video helpful, then please click the like button. And also consider subscribing to my channel where you'll find more A-level maths videos. Thanks for watching.